As we pull back from the stories of Voyager and its incredible odyssey, our gaze now shifts, not to spacecraft, but to the fabric of space itself. Consider the haunting beauty of a black hole, a gravitational monster so dense that even light cannot escape. When you observe an image of a black hole, like the now famous rendering of its glowing ring, you might notice something strange. The light appears to wrap around not just the equator, but also across the top and bottom. It gives the illusion that the black hole has rings on all sides, almost like Saturn in shadow. But here's the truth. Those aren't separate rings. What you're seeing is the same ray, bent by gravity. The immense gravitational field of the black hole warps space-time so drastically that light rays traveling upward or downward are curved back toward the observer. You're seeing both the front and back of the ring at the same time. This phenomenon, called gravitational lensing, is one of the most mind-bending and beautiful effects of Einstein's general relativity. And this brings us to a deeper question. What does gravity do to the shape of space itself? In a flat universe, everything follows straight lines. Space behaves like a calm ocean, predictable, linear, simple. But what if those lines bend? What if space itself is curved? In a positively curved universe, the lines of reality, light rays, gravitational paths, even time itself, begin to converge, like lines on a globe. Imagine trying to draw a straight path across a sphere. Eventually, every straight line bends inward. This suggests a closed universe, finite but unbounded, like the surface of a balloon. In contrast, a negatively curved universe stretches outward forever, expanding like a saddle into infinity. So, which one do we live in? That's still one of the great unsolved questions of cosmology. But missions like Voyager and telescopes like James Webb help us get closer to an answer. They gather data about cosmic background radiation, gravitational waves, and galaxy distribution. Data that helps map the geometry of the universe itself. It's humbling, isn't it? A spacecraft built in the 1970s, drifting alone in the dark, still contributes to our understanding of something as vast and philosophical as the shape of existence. That's the beauty of science. It begins with simple questions. Where are we going? What's out there? And it leads to profound truths about what we are made of, what reality is, and how the universe will end. At Infinity Beyond, we believe that stories like Voyager are more than historical footnotes. They are all living stories. They are still unfolding, still whispering. From the cold edges of our solar system, to the bending of light around a singularity, to the curvature of all space, every discovery, every signal, every faint photon caught in a telescope, it all speaks to one thing. We are part of something far greater, something elegant, mysterious, and waiting to be explored. So whether you're a scientist, a dreamer, a stargazer, or someone hearing this for the first time, let Voyager be your inspiration. Let it remind you that we came from dust, but we reach for the stars, and that somewhere out there, beyond gravity, beyond time, beyond even the pale blue dot, a spacecraft still drifts quietly, carrying the story of who we are. And maybe, just maybe, that story is still being written.